the unpredictable fury of the sun, solar storms, superflares, and the hidden threat to Earth. It's easy to forget that our sun, the warm, life-giving orb in the sky, is not just a steady, glowing ball of light. It is a raging, roiling nuclear furnace, filled with magnetic chaos and violent outbursts that can shake our planet to its core. It may seem stable to us, but in truth, the sun is dangerously unpredictable. And this fact was driven home once again just a few months ago, when NASA recorded the strongest solar flare in almost 2 decades. The event was so extreme that its effects rippled all the way to the bottom of the ocean, distorting compass data in an underwater sensor network off the coast of Canada. This wasn't science fiction. It was a stark reminder. When solar storms hit, they don't just create pretty auroras. They can disrupt satellites, take down power grids, scramble GPS signals, and paralyze global infrastructure. But what exactly are solar storms? Where do they come from? And why have we been underestimating their danger for so long? Let's dive deep into the very heart of our star and uncover the violent secrets hiding beneath its radiant surface. Milky Way, a flash from the past, the Carrington event of 1859. To understand the scale of solar storms, we need to go back in time, over 160 years, to a fateful morning in early September 1859. Astronomer Richard Carrington, an English scientist known for his careful observations of sunspots, was working in his private observatory in Surrey. Using a telescope and projection method, Carrington traced the dark spots that regularly appeared on the surface of the sun. But on September 1st, he saw something no one had ever seen before. As he watched, 2 brilliant points of light suddenly flared above a cluster of sunspots. These bright flashes intensified rapidly and then merged into a blinding, kidney-shaped flare. Within a minute, the light dimmed again, but the moment had already become immortal. What Carrington had witnessed was the first recorded observation of a solar flare. But the real fireworks were still to come. Rainbow, the night, the skies burned bright. Within hours, intense auroras began appearing across the globe. But these weren't the usual northern lights seen in polar regions. These auroras were so bright you could read a newspaper by their glow. They were spotted in places where such lights had never been seen before: Jamaica, the Bahamas, even Hawaii. Telegraph systems, the pinnacle of modern technology at the time, were thrown into chaos. Operators experienced electric shocks. Paper caught fire spontaneously from electrical surges, and telegraph lines continued to transmit messages even after being shut down, charged solely by the energy of the storm itself. People were baffled and terrified. At the time, no one could explain what had happened. Today, we can. High voltage, the science behind solar storms. The Carrington event, as it came to be known, was caused by an explosive solar flare, accompanied by a coronal mass ejection (CME), a gigantic cloud of electrically charged plasma hurled into space. When this CME slammed into Earth's magnetosphere, it distorted our planet's magnetic field, unleashing a storm of particles into the atmosphere. These particles collided with molecules of oxygen and nitrogen, creating the stunning auroras. But they also induced powerful electric currents on the ground, short-circuiting infrastructure that wasn't remotely prepared. It remains the most powerful geomagnetic storm in recorded history, and a chilling preview of what might happen again. Cyclone, the solar cycle, a magnetic heartbeat. The sun isn't always this violent. It follows a predictable, though highly complex, rhythm known as the solar cycle, which lasts roughly 11 years. During solar minimum, the sun is relatively calm. During solar maximum, sunspots multiply, magnetic fields tangle, and solar flares erupt more frequently. The cycle isn't just about sunspots. Every 11 years, the sun's magnetic poles flip, and deep within its convection zone, where superheated plasma churns in vast circular currents, differential rotation causes magnetic fields to twist and snap like rubber bands under tension. When this magnetic energy builds up and can no longer be contained, the sun erupts, producing flares, CMEs, and massive bursts of ultraviolet and X-ray radiation. These ejections race through space at speeds of up to 3,000 kilometers per second. And when they reach Earth, they can wreak havoc in ways we're still struggling to fully comprehend. Globe showing Europe, Africa. What happens when a solar storm hits Earth? Our planet is shielded by a magnetic field, the magnetosphere, that deflects most of the solar wind. But during a solar storm, the energy overwhelms this defense. The magnetosphere warps, and currents of charged particles surge into the upper atmosphere. At first, this creates spectacular auroras. But the danger goes much deeper. Voltage surges are induced in power lines and transformers. Satellites may be damaged, disabled, or thrown off course. GPS accuracy plummets, disrupting aviation and navigation. Radio communication blackouts can affect vast regions. Even underwater cables and ocean sensors can be affected. Compass deep-sea evidence. A solar storm reaches the ocean floor. This is not theoretical. In May 2024, a solar superstorm of class G5, the highest level on the space weather scale, struck Earth. It was the most powerful event of its kind in nearly 2 decades. And for the first time ever, scientists measured its effects at the bottom of the ocean. Ocean Networks, Canada operates a vast network of underwater sensors designed to monitor ocean currents and seismic activity. But in March 2024, researcher Alex Slimer noticed a strange anomaly: simultaneous magnetic field disturbances across multiple deep-sea sensors. When the superstorm hit in May, the data showed magnetic field deviations even at depths of 2,700 meters. In shallower waters near Vancouver, compass readings were off by up to 30 degrees, a staggering deviation, especially for instruments designed to be precise. This proved something astonishing. Solar storms can reach and disrupt systems even on the ocean floor. Brain, have we underestimated the danger? Historically, scientists assumed that superflares, those vastly more powerful than even the Carrington event, were rare, perhaps occurring once every 1,000 or 10,000 years. But recent research has shattered that assumption. A team at the Max Planck Institute for Solar System Research analyzed data from over 56,000 sun-like stars observed by NASA's Kepler Space Telescope. Their goal: determine how often these stars produce superflares. The result? They found 2,889 superflares across 2,527 stars, suggesting that these massive events happen roughly once every 100 years on stars like our Sun. In other words, our Sun is capable of far more powerful outbursts than we thought, and they're far more frequent. These superflares could be 10 to 10,000 times stronger than the Carrington event. And if one were to strike Earth, the consequences could be catastrophic. Stop sign: what would a modern Carrington event look like? Imagine this: nationwide power grid failures, lasting days or even weeks. Financial systems offline. Global GPS outages, grounding planes and disrupting supply chains. Internet blackouts as satellites and ground stations fail. Oil pipelines, trains, and emergency services disrupted by failing communications. A study in the journal Space Weather predicts that a modern-day superstorm could cause trillions of dollars in economic damage and take years to fully recover from. Shield, what can we do? Unfortunately, there's no way to stop a solar flare or CME. The best we can do is prepare. Space weather observatories like NASA's Solar Dynamics Observatory and ESA's Solar Orbiter provide early warnings. Power companies can temporarily shut down vulnerable transformers. Satellites can be put in safe mode. Astronauts can seek shelter from radiation bursts. But such measures require timing, coordination, and advance notice. In many cases, we might have just 12 to 24 hours between detection and impact. Telescope, what comes next? We are currently approaching the peak of solar cycle 25, expected to reach maximum activity in late 2024 to early 2025. This means more sunspots, more flares, and more solar storms in the coming months. Experts warn, events like the May 2024 storm may become increasingly frequent. And though we hope to avoid a Carrington-level disaster, the truth is that our preparedness is still lagging behind the threat. The Sun is not a peaceful guardian in the sky. It is a volatile star with the power to transform our world in a matter of hours.